So now that the server is up and running and the domains are pointed to the right IIS servers and all the certificates are in place, I can finally focus on some coding. In this video, I'll use the AspNetCore Web API template to build upon the API that I'll create. I will create or enable versioning. I will install MySQL on the server and display a small record set when connected to an endpoint. I will also set up CORS or cross-origin resource sharing, enable bearer tokens for authorization, set up SignalR for socket connections, set up rate limiting to safeguard the API from abuse, create cron jobs that run every minute and every day, and even set up a mail server that can process incoming emails. In the end, I will publish the whole thing via FTP right out of the IDE. So let's fire up Visual Studio 2022. Before I start the project, let me show you what extensions I've installed. There's a highlighter component that highlights when I have to-dos in a comment. I have ReSharper installed, but most importantly, I have GitHub Copilot installed. That is a real time saver. And with that, I'll go right into creating the project. I choose Web API from the options, give it a name, and leave everything else at defaults. And after a second or two of loading, I have the project that is actually running out of the box. Now that I know the base template works, I go right into versioning. It's easier to do this now than trying to do it later when everyone is already using the API. I install the ASP versioning MVC API Explorer package, as well as a swashbuckle AspNetCore filters. I also update swashbuckle and go back into my program CS file, which is the main startup file for the project. Here I integrate versioning by adding it to the builder. I tell it to report versions, assume a default version of 1.0 when unspecified, add MVC, and tell the API Explorer to add the API version in the URL. I take Swagger and Swagger UI out of the development branch so it runs in the production environment as well. Then I create a version description provider and modify add SwaggerGen with some options. Swagger is a tool that displays all the endpoints neatly that we just saw in the HTML page. I add the bearer option so we can authorize calls inside Swagger. Give it a description and tell it where and how to authorize it. Then I tell Swagger to loop through all versions and create a doc with the appropriate title and description for each version. I define the name and path of the XML file and tell SwaggerGen to include comments in that XML file. This is a nice feature as it will show descriptions for each endpoint. Then I'll go into the weather controller the template came with and edit the route to include the version. I fire up the project and realize it's not working. Then I remember I have to go into the project settings and enable to generate a documentation file. I start up the project again and get yet another error. This time Swagger comes up but gives a load definition error. I clearly need to change some options when the app starts and use Swagger and use Swagger UI. And again I have to loop through each version of descriptions. I don't want the models to show at all, so I set the depth to -1, give the API a title and start it up again, and this time Swagger works as expected. You can see the endpoint is preceded with a V1 now. There's also an authorize button to the right. Next up is CORS or cross-origin resource sharing. In older versions of .NET you could just allow all origins, all headers and all methods, but that's not possible anymore. I don't notice here that I fat errored builder twice, which will lead to some errors and confusion in a minute. The origins that I'm entering are just placeholders. I'll have to change them later once I know what port my development front end will be running on. I'm also adding a special wildcard exemption because each client will have his or her own subdomain. I'm also telling the app to use CORS on startup, referencing the CORS policy name that I specified in the service builder. Here I can't figure out what I've done wrong. Sometimes the nested arrow functions can get confusing. I'll fast forward here to the end. And voila, the project compiles and runs through the magic of editing. Next, I'm adding support for JSON Web Token Bearer, which helps with authorization of calls that are coming through the API. I'm installing the Microsoft AspNetCore Authentication JWT Bearer package. I define what values make the token valid, so it will require valid issuer, audience, lifetime, and signature. The key will come from the app settings JSON file, and I'm entering a very secure passphrase here. I suggest you enter your own to make this more secure. Next, I will be adding SignalR that will enable bidirectional real-time communication between the API and the client. So I go back to the NuGet package manager and install Microsoft AspNetCore SignalR Common. I also install Message Pack that will allow for more efficient transfer of data, as well as SignalR Swagger Gen, which will allow me to list SignalR methods right inside Swagger. So I'll first add SignalR to the services builder and add some configuration that is more of a niche problem I ran into in the past. I don't expect this here to be a problem. The standard configuration is probably just fine. I'll also configure the builder to add the Message Pack protocol to the service. Inside Add Swagger Gen, I add SignalR Swagger Gen and add the hubs method to Swagger. It's not necessary, but more like nice to have. Then I create a hubs directory in the project folder and add a socket hub class that derives from hub. I inject iConfiguration into this class and create a simple async method sendAnnouncement that will send a message to all connected clients. I decorate the class with SignalR Hub to make sure it is being picked up by Swagger. And go back to Program.cs to add the hub to the app builder. Here I define the hub's endpoint as socket. I also add the class scope to the services builder so I can direct inject it into other classes when needed. I fire up the project and here's the socket hub listed with a method in Swagger. Now it's time for some data. I'll go back to the server and download MySQL. I'll fast forward the installation process here. Make sure to note down the logon credentials as you're going through the setup process. I use MySQL Workbench locally and create a database with a simple users table. I create a few records and save the changes. Before going back to the API project, I will create a firewall exception on port 3306. Back in the project, I add two connection strings to the app settings JSON file, one for reading and one for writing. Here they are identical, but they might not be if you have a cluster. Next, I add the Pomelo Entity Framework Core MySQL package to the project and go back to the program file to add 2 DB contexts to the builder. They don't exist yet, but not for long. For each, I reference the connection string from the app settings JSON file. Next, I create a folder called core. I add a data context file to it that actually consists of two classes, the write context and read context class, both derived from DB context. I overwrite the onConfiguring in case the configuration gets lost during the lifecycle of the application. This is basically the same configuration that was selected for the services builder. Then I add a DB set of user to the class that doesn't exist yet. I'll create this next and add it to the entities folder that I'm creating. This class will mimic the database table as closely as possible. This is just a test. Normally I would decorate the fields some more, especially the ones containing varchars. I forgot to make the ID and name public here, something I'll have to come back to shortly. I go back to the weather forecast controller and direct inject both read context as well as write context into the class. I then create a new getEndpoints that lists all users. Normally you never use entities, but instead use DTOs or data transferred objects instead. But for testing purposes, I will directly list the entities. I'm running into the problem not making the properties public though. Finding this error takes me a couple of seconds. And here's the endpoint with the JSON data showing. Next, I'll add rate limiting to the project, which is a pretty important feature for stability. It is supported out of the box by AspNetCore and just needs to be enabled and configured. So I configure the add fixed window limiter to allow for 10 calls within 20 seconds, which seems plenty. When the limit is reached, the API will respond with a status code of 429. Then I'll go into the weather forecast controller and decorate the class with the limit I've just created. And finally, I add rate limiting to the app so it's enabled. After firing up the debugger, I realize the behavior is not what I wanted. After 10 requests, the API simply waits for the window to pass instead of throwing a 429 error. So I set the queue to 0 and remove the processing order, and in the end this is the behavior I'll be going with. Here you can see the API returning 429 after the 11th request within 20 seconds. I go back into the NuGet manager and install Quartz. Then I create two classes, cron minutely and cron daily, both deriving from iJob. I'm injecting each cron class with the iConfiguration and create an async task called execute. This task will be called either every minute or every day. Going back to the program.cs file, it is now time to configure the cron job. But I noticed that I installed the wrong NuGet package, so I uninstall Quartz and install quartz.aspnetcore instead. Back in the program CS file, I tell Quartz to use simple type loader, in-memory store, as well as use the default thread pool with a max concurrency of 10. Then I define two job keys and add the classes as jobs to Quartz using the job keys I've created. Then I define two triggers that will trigger each of the jobs. The minute job will run on top of every minute. The daily job will run on 10:06 AM UTC, which is in the middle of the night in the US. In the end, I tell the builder to add Quartz as hosted service. Lastly, I go back to the NuGet manager and install SMTP server. I create a class called SMTP worker in the core directory, which derives from background service. I inject SMTP server into this class and override the execute async method, which starts the SMTP server. Right underneath, I create another class called console message store, which derives from message store. Once again, I inject iConfiguration so it's available in the class. I then override save async, which handles incoming emails. I need to take the buffer and convert the byte stream back into an actual email message. For this, I install the package MailKit, which is an open source mail client library. Back in Program CS, I add SMTP server as singleton to the service builder. I define the server name, port, and the message store with the class I've just created. Just like Quartz, I add SMTP worker as a hosted service. And with that, I test the project one more time and it seems to be working as expected. There's one last thing I want to do, which is enable access tokens for SignalR. I'm going into the add JWT bearer method and hook into events. SignalR sends a token as query string, so I capture that and check if the path equals the socket hub. If so, I'll set the context token to the query string token that was captured. And finally, I set up to publish the project to the server via FTP. I stop the application pool, otherwise there will be a file access conflict. I hit publish and the IDE does the rest. After enabling the application pool again, I can now access the API via api.painless.events. So this was certainly a lot of information and it took some time to set up. It's nighttime already. It will build the framework for our backend. In future videos, we'll focus less on the startup file and more on the controllers, DTOs, entities and core classes, which we just barely touched upon. Tomorrow I'll create the front end and make a quick call to the weather forecast endpoint, as well as test out some of our SignalR real-time functionality.